Alright guys, so this is geometry. So this is 8.1, similar shapes and scale drawings. And again, your objective is to be able to use scale drawings to solve problems and with at least 80% accuracy given independent practice. We have two vocabulary words: scale, which is the ratio between two sets of measurements. It basically shows the dimension and the scale and how their scale is related to the actual drawing. So this you'll see in architecture drawings and any plans, any engineering drawings as well. And then the scale drawing is basically the proportional to the drawing that you see that is similar to the actual shape or the object. It's represented with either smaller or larger than the actual object. So let me just kind of give an example. So for instance, when you have a floor plan of a house, right? Or like, I'm going to draw an elevation so you can see it. So for instance, this is the big paper, right? And then you have elevations. So for instance, you have this, right? And that's how the house looks like. So that's the front of the house, right? But that is actually not the size of the house. So that's a scale drawing. It shows the shape of the front elevation of how the house looks from the front, but that's not how big the house is. So you might see something that says 1 inch equals, I don't know, 3 feet, right? So that will be the scale for that. So that means that every inch that you have drawn on the drawing on the picture is actually in reality 3 feet. Okay, so that's basically what it is. So in this case, the drawing looks smaller than the actual object. But for instance, if you have like a tiny thing, like a little screw, right? And you have a drawing that actually looks like that. So this is not how the screw is. That's actually enlarged. So then you'll see something that maybe says 1 inch equals 1/4 of an inch. That means that every inch that you have drawn here is actually only 1/4 of that. So that means that it's 1/4 of the actual drawing. Okay. So let's go to find dimensions, and then we'll draw something to scale, and then we'll get it. We'll use our scale drawing to find area of an object. Okay. So let's get to it. So the first one is to find the dimensions. So the first thing we're going to do is we're going to set up a proportion. We're going to be able to make sure that you match the units. And then you solve for that value that is not given to you. Okay. So I don't know what that was. So in this case, we're given the scale, which means they're telling us that every 4 inches. So like if you have a drawing and it's every 4 inches, it's actually 3 feet. So every 4 inches is actually 3 of these rulers. So again, the drawing shows 4 inches, but in reality, those 4 inches are 3 feet. So that means that the drawing is smaller than the actual object. Okay. So we want to know the real size of that object. So if, for instance, I see a line that is 12 inches in the drawing, how long is it in reality? Okay. So then I can set up a proportion and say, okay, 4 inches equals 3 feet, right? In my scale. And then I'm going to match it up. So I'm going to create a proportion, and I'm going to match my inches to where I see the inches, because that's what I'm given in the drawing, right? I'm given drawings. This is my drawing right here. So then I have 12 of those, right? I have 12 inches in my drawing, and I want to see how many feet that is in reality. So then you have to use butterfly effect. So then I can do this. So that will be 12 times 3 is 36, and then divided by 4, which is 9. So that's 9 feet. Okay. So that's the way to do it. I know that some of you find different ways to do it. As long as it's reasonable and it's justified, you justify the steps, then you're fine. So in this case, a 12-inch line in reality is 9 feet long. Okay. So let me go ahead and give you one to do for this. That's not here. But so I have a 2 inches in a drawing. It's actually 3 feet. So if a line is 5 inches in the drawing, how much is that in real life? Okay. Let me go ahead and go to this one, and I'll do this one last. So we're going to use the scale drawing to find area. Before we get anywhere, we have to remember the area, at least of a rectangle, is found by multiplying the length times the width, or the base times the height, which is the same thing. The scale to find the area. This is a drawing, and I need to figure out the actual size first. And the scale given to me was 2 inches equals 3 feet. Okay? So 2 inches equals 3 feet. So again, I'm given what is in the drawing. I need to figure out the actual. So I'm going to set up a proportion. So then I have 2 inches equals 3 feet. And I know my inches for the drawing. So this is 28 inches, and I don't know how many feet. So I'm trying to figure this out. So I'm going to do the butterfly effect, or you can go ahead and say 2 times 1 gives me 3, which is 1.5. So when I do top, I do to bottom. So 28 times 1.5 is basically itself plus half of it. So that gives you 42. So that means that this is 42 feet. You want to do the butterfly effect, you'll get the same thing. So 28 times 3. 24 carry the 2 over. 3, 6 plus 2 more, that's 84. Divided by 2 is 42. So again, you get the same answer. And then I'm going to do the 11. Okay, so that's a 42. So then I have a 42 feet by, let's figure out the 11. So 11 goes right here. So again, I can do I can do the multiplication factor, which is 1.5. But if not, then you can do the butterfly effect. So 3 times 11, that's 33. And then you divide it by 2, which is 16.5. And to find area, I have to multiply length times width. So I'm going to multiply 16.5 times 42. So 2 times 5 is 10, 0, carry the 1 over. 2 times 6 is 12, plus 1 more, 13, carry the 1 over. 2 times 1 is 2, plus 1 is 3. Erase that so you'll get confused. You skip a place value, and then you start with the 4. 4 times 5 is 20, 0, carry the 2 over. 4 times 6 is 24, plus 2, that's 26, carry the 2 over. 4 times 1 is 4, plus 2 is 6. Add them together. And there's a decimal here, 1 digit to the right, so 1 digit right here. So then this is the area. So area is 693 square feet. Okay? So let me go ahead and give you one to do. Go ahead and find the actual size. So you're going to give me the actual size. So you're going to say this by that. Make sure you tell me meters. And then right here, you're going to find the area. Make sure that you have meters square for the area. Okay? Alrighty. So last one. So we're going to take the given scale and draw accordingly. So I'm going to use the same scale, but I'm going to go backwards now. So I'm going to say that there's a room that is, let's say that this is 6 meters wide by 18 meters long. Okay. So we want to figure out how big I have to draw that. So then I'm going to use the same proportion. So I have 2 centimeters equals 3 meters. Now I'm given meters because that's the actual size. So then I can write 18 here for the first one. And then I do 18 times 2 is 36. And 36 divided by 3 is 12 centimeters. So then my drawing has to have 12 centimeters here. And then for the width, this is 6 meters. 6 times 2 is 12 divided by 3